Hi to everyone. I am Dr. VNSR Venkateswara Rao, working as Associate Professor from the Department of Chemistry in Institute of Aeronautical Engineering, Hyderabad. So today I would like to give the topic on the mainly fuels. So in the fuels, I explain the what is the definition of the fuels. After that, we see classification of the fuels. Next, I explain about solid fuels, including its proximate analysis. So before starting the topic, first we see what are the contents involved in today's section. So first one, introduction to the fuels. Next one, we see what are the classification of the fuels based on their availability and physical state of the fuels. After that, we see comparison between the solid, liquid and gaseous fuels. After that, we see characteristics of a good fuel. Next, we see introduction to the solid fuels and finish the topic with the proximate analysis of the solid fuels, nothing but the coal. So first of all, we see what is the introduction to the fuel. So first of all, everybody know about the fuel. Fuel is nothing but a combustible substance which gives combustion products in the presence of air undergoes combustion reaction, and this combustion reaction gives the heat energy. So that's why this is called exothermic reaction. That means what is the meaning of exothermic reaction? The energy proceeds or the reaction proceeds by the absorption of the heat energy. That is nothing but a endothermic reaction. And exothermic reaction is nothing but the reaction proceeds by the liberation of the heat energy. That means exothermic is nothing but the reaction proceeds by the liberation of the heat energy. Endothermic means the reaction proceeds by the absorption of the heat energy. So that means a fuel is a combustible substance which on proper burning produces a large amount of the heat energy. That means the heat evolved during the combustion can be used economically for industrial and other uses. So that means, for example, if you can consider the coal is used in locomotives and as reducing agent in blast furnace. That means petrol is mainly used in internal combustion engines and for doing mechanical work. So that means these are solid, liquid and gaseous fuels that are available for firing gun boilers and furnaces and other combustion equipment. That means right type of the fuel can be selected depending on the various factors such as storage, availability, handling, pollution and landed cost of the fuel. That means combustion is the process of a chemical reaction between the fuel with the oxygen. That means this combustion reaction is very, very important in case of the fuels. Why combustion is important fuels? Why? Because it gives the large amount of the heat energy. That means combustion is the one of the reaction. That means the fuel undergoes the oxidation and it gives the combustion product by the liberation of the heat energy. So that means during combustion, heat and products of the combustion are released. That means the combustion process is an exothermic chemical reaction. That means already we discussed exothermic nothing but the reaction proceeds by the liberation of the heat energy. That means the reaction that releases the energy as it occurs symbolically. Combustion can be represented as nothing but when fuel reacts with the atmospheric oxygen. That means the oxygen can act as an oxidizer to give the products of the combustion with the elimination of a energy. That means we see if the what are the fuel components, nothing but carbon and hydrogen. So these are the elements of the fuel. When carbon reacts with the oxygen to give carbon dioxide, and hydrogen reacts with the oxygen to give what happens? Water vapor. That means H2O plus O2 gives rise to He2O. So these are the chemical reaction. That means when carbon reacts with the oxygen to give CO2, H2 plus O2 gives rise to H2O, including we give the energy. That means heat energy. So this is the combustion reaction occurred by the fuels when it undergoes the oxidation in the presence of a oxygen. That means heating value of a fuel is the amount of energy or heat released per unit mass during combustion of that fuel. That means the heating value of a fuel is very, very important. And the main elements of the combustion are the carbon, hydrogen, sulfur, oxygen and nitrogen. That means including the main elements carbon, hydrogen and some traces elements also involved in the combustion, nothing but sulfur, oxygen and nitrogen. That means with the advent of the nuclear fuels which generate heat by the nuclear reaction, and the common fuels may be termed as a chemical fuels. So that means now we see what are the classification of the fuels. First one based on the occurrence, natural or primary fuels, and second one is nothing but artificial and secondary. That means first of all we see the occurrence of the fuels takes place primary and secondary. Primary means that means the fuels directly obtained from a nature. So those are called primary fuels, natural fuels. And secondary fuels are obtained from the natural fuels by chemical reactions. Those are called synthetic fuels. So this is mainly depends upon the occurrence of the fuels. And second one is nothing but a physical state of the fuels. So physical state is nothing but again classified into three types. First one solids, second one liquids, and third one gaseous fuels. So that means physical state of the fuel nothing but solid, liquid and gas are state of the aggregation. Nuclear fuels are nowadays used for power generation. It includes nuclear fuels are nowadays used for power generation. And what are the examples for the nuclear fuels? Nothing but uranium 92 235 and plutonium 239 94. These two are coming out from a actinide series from the periodic table. And we see the examples. First one, natural fuels, nothing but some of the fuels found in the nature and are used in the same form. These are called natural fuels. What are the examples? Wood, coal, natural gas and petroleum. And second category, artificial fuels. These are also called secondary fuels. The fuels that are derived from the natural fuels are called artificial or secondary fuels. What are the examples? Nothing but petrol, producer gas and charcoal. So now we see pictures diagram for the types of the fuels based on the physical state. So first one, these are mainly classified into three types: solid fuels, liquid fuels and gaseous fuels. In solid fuels you see the diagram, nothing but this is the pieces of the wood and we obtain it from the coal mines, from the coal stone. These are the examples for a solid fuels. And this coal mine stone will be grind by the uniform size particle, that is nothing but a charcoal. And liquid fuels. So what are the liquid fuels? Used for the lamps as a kerosene. And for the transport purpose, we use the petrol and diesel, especially in the case of the cars. And third one is nothing but gaseous fuels, which are used in also transport purpose, especially we see in cities CNG, compressed natural gas cars, and also we use the domestic purpose LPG, liquefied petroleum gas, and biogas and hydrogen gas. All of these examples for gaseous fuels. This is about the classification of the fuels based on its physical state. And now we see the comparison between solid, liquid and gaseous fuels and advantages and disadvantages. So this table shows the what are the advantages and disadvantages of each and every fuel based on its physical state. That means nothing but solid, liquid and gaseous state. First of all, in solid fuels based on economy, these are very cheap and easily available. Liquid case, costly and available only in a few countries and obtained from the mines. In gaseous fuels, more costly than the solid fuels. So with respect to cost, solid fuels are the better. And the second one, as it does not burn spontaneously, its storage, transportation and use is easy. That means transportation in the case of liquid fuels is easy and storage needs care. In the case of the gaseous fuels, transportation is easy but storage is risky. Very large storage tanks are needed. So with respect to storage, solid fuels are better. And third one, low risk of the hazards. And liquid fuels, more risk as they are highly inflammable. And gaseous fuels, high risk of the fire hazards. So with respect to risk also, solid fuels are better. And fourth one, slow combustion rate. And liquid fuels, quick combustion. And gaseous fuels, very fast combustion due to uniform mixing of the air and fuels. So that means with respect to the reaction involved in the fuels, nothing but combustion reaction, gaseous fuels are very important. And fifth one, nothing but with respect to ash. In case of the solid fuels, the ash content is more. In case of liquid, there is no formation of ash, and gaseous fuels also there is no formation of ash. That means with respect to ash content, gaseous fuels are better. And sixth one, cause more pollution. Liquid fuels less pollution, and gaseous fuels least pollution due to uniform mixing of the air and fuels. So with respect to pollution also, because of the formation of ash content from the solid fuels, it produces so much of the pollution. So with respect to pollution, gaseous fuels are better when compared to solid and liquid. And seventh one, lower calorific value and lower thermal efficiency. And liquid fuels higher calorific value, and gaseous fuels also higher calorific value. So with respect to calorific value, liquid fuels are better than solid fuels, and also gaseous fuels are better than liquid fuels. That means the next one, more oxygen is required for the combustion and burn with clinker formation. In the liquid fuels, less oxygen is required for the combustion than the solid fuels, and gaseous fuels, least oxygen is required for combustion. So with respect to requirement of the oxygen, gaseous fuels are better than remaining solid and liquid fuels. And it cannot be used in vehicles as fuel. It's liquid fuels mainly used in the vehicles, nothing but especially IC engines, internal combustion engines. And gaseous fuels also used as a fuel for vehicles. It is also used in internal combustion engines and autos and transport purpose. And combustion process of the solid fuels cannot be controlled easily. But in the case of the liquid, combustion process can be easily controlled by regulating the flow of the liquid fuels. And in the gaseous fuel, combustion can be readily controlled for changes in demand like oxidizing and reducing atmosphere, length of the flame, temperature, etc. That means with the help of the regulation capacity, the combustion reaction should be controlled in the case of the liquid and gaseous fuels compared to the solid fuels. And the products of the combustion escaping into atmosphere as flue gases are associated with the ash are should. And the products of the combustion in case of liquid fuels are relatively clean from the dust, soot, etc. And in the gaseous fuels, complete combustion occurs without pollution due to uniform mixing of air and fuel. That means with respect to combustion products also, liquid and gas fuels are better than the solid fuels. So this is about the comparison between the solid and the liquid fuels. And now we see what are the characteristics of a good fuel. So these are the characteristics. First of all, the fuel should be available in cheap and low cost, and it should be dry and should have the low moisture content. And dry fuel increases its calorific value, and it should be easily transportable. Otherwise, the cost of the fuel will be increases, and it must have the higher calorific value, and it must leave ash after combustion. In case of the more ash, the fuel gives the less heat. And the combustion speed of the good fuel should be moderate. Otherwise, will not solve the problem of the heating. So it must have the moderating ignition temperature. Lower burning ignition temperature can cause the fire accident, and it should not burn spontaneously to avoid the fire hazards. It should not give the harmful gases after the combustion, and its handling cost should be easy. And the combustion of a good fuel should not be explosive. And the combustion of good fuel should not result in the release of the toxic gases like carbon monoxide, carbon dioxide, and methane gases, etc. So this is about the characteristics of a good fuel. After that, we see what are the solid fuels. Before starting the solid fuels, first of all, we see how to formation of the solid fuels. That is explained in the introduction to the solid fuels. So, what are the examples of the solid fuels? Nothing but wood, coal, charcoal. All are these examples of a solid fuels. So, because of the environmental hazards, trees were buried inside the earth by the action of temperature, pressure, and bacterial actions over the period of thousands of years. They converted into brown black solid name that is nothing but a coal material. So that means we see the reaction. Generally, the wood present in the solid fuels in the temperature and pressure and bacterial action that will be converted into a coal. So coal is the best example for a solid fuel. So since wood contains a higher carbon percentage in the form of cellulose, lignocellulose, they are transformed into the form of a coal. So the process of conversion of wood into coal is called qualification. So depending upon the percentage of the carbon, hydrogen, moisture, and calorific value, 4 different types of the coals are exist. So it is called as a ranking of a coal. So dry wood has the following composition: carbon 48 to 50%, oxygen 42 to 44%, hydrogen 5 to 6%, and traces of the minerals. That means the calorific value of the wood is nearby 4000 to 4500 kilocalories per kg and is used as a domestic fuel. So, wood can be converted into charcoal by a process called carbonization. So, that means destructive distillation of the wood. That means charcoal is used as the absorbent of the gases and for decolorization of the sugar. That means it is a carbogenous matter produced by the decomposition of vegetable and animal matter buried inside the earth's crust or under oceans. That means it is a non-renewable energy source formed by the decomposition of accumulated vegetation over a period of millions of years. That means coal is one of the major sources of the energy in many industries such as steel, cement, and paper because of its easy availability and least risk of fire hazards. And now we see analysis of the coal. So before analysis of the coal, just we see the definition of a ranking of the coal. During qualification of a wood, the first stage of the coal is peat, and it is ranked the lowest among the coals. It is ranked the lowest among the coals, and other coals are lignite, bituminous, and anthracite. So it has been reported that graphite is also the final stage of the qualification. So that means wood, peat, lignite, bituminous, anthracite. From wood to anthracite, the percentage of the carbon and hydrogen will be gradually increases, and automatically the calorific value also increases. Finally, the anthracite having the higher calorific value, that means it is nothing but a high rank coal. That means peat and lignite are called as low rank coals. Bituminous and anthracite are called as a high rank coals. And there are totally two types of the analysis of the coals are involved. The analysis of the coal is helpful, it's ranking. That means the assessment of the quality of the coal is carried out mainly by the following two types of the analysis. One is proximate analysis and second one is the ultimate analysis. Now explain what is the proximate analysis. So, proximate analysis gives the information regarding the practical utility of the coal. That means in this analysis, the percentage of the carbon is indirectly determined, and this analysis includes the percentage of the moisture, volatile matter, ash content, and carbon. So that means it involves mainly four contents. First one is moisture, second one is the volatile matter, and the third one is the ash content, and final one is nothing but fixed carbon. Now let us see the first content, moisture. So for the moisture determination, first of all, a known mass of the finely powdered air-dried coal is taken in a crucible and it is heated up to 110 degrees for an hour and cooled at a room temperature in a desiccator. That means the moisture is removed as water vapor and the process is repeated. That means the weight of the coal is repeated on the percentage of the moisture basis till the constant weight is obtained. That means after the completion of the entire process, what happens because of the elimination of the water vapor, the weight of the coal will be reduced from initial stage to final stage. That means now we can calculate the percentage of the moisture. It is looks like say the percentage of a marks obtained from the after completion of each class. For example, if you can complete the recently SSC, that means 10th class. If anyone asking you what is your percentage, nothing but the percentage of the class. It depends upon the percentage of the marks, nothing but obtained marks by total marks. Obtained marks by total marks into 100. So this is nothing but percentage of the marks. Like this formula, we also obtain the percentage of the moisture. Why? Because we have the two weights. First one is initial weight and the last one is the final weight. So that means because of the moisture content, what happens? The weight will be reduced. That means we consider the final weight nothing but loss of the weight of the coal by weight of the total coal. Weight of the coal taken into 100. That means loss of the weight of the coal divided by weight of the coal into 100. So this gives the percentage of the moisture. And second one, nothing but volatile matter. That means dried sample of the coal left in the crucible is covered with a lid and placed in a muffled furnace maintained at 950 degree centigrade exactly for 7 minutes. So these are the conditions for volatile matter. Maintain temperature 950 degrees and required time is 7 minutes. That means the crucible is then taken out cold in air and then in a desiccator and weighed. It is also lost the weight of the final weight of the coal. Why? Because the volatile matter gets evaporated. That means the loss in weight is reported as the percentage of the volatile matter. That means percentage of the volatile matter is equal to loss in weight of the coal due to removal of the volatile matter divided by weight of the coal into 100. And the third one is nothing but ash content. That means coal free from the moisture and volatile matter is heated again in a crucible up to 700 degrees centigrade. That means in a muffled furnace in the presence of the air. That means in the presence of a air. In the presence of air, we can burning the coal in order to get the ash content. That means it undergoes combustion and results in the formation of a ash. That means crucible is cooled to room temperature and weighed. That means heating, cooling, weighing is repeated to get constant weight of the residue. The residue is reported as a ash. That means the mass of the ash is then determined. That means percentage of the ash is equal to mass of ash into mass of the coal. That means we can determine the percentage of the ash, mass of the ash by mass of the coal into 100. And final one, nothing but carbon. So we see the total proximate analysis. It contains totally 4 contents. First one is the moisture. And second one is the volatile matter. And third one is the ash content. And fourth one is nothing but fixed carbon. So out of the 4 contents, 3 contents are over. That means we consider overall 10% of the analysis, 75% of the analysis is over. The remaining 25% of the analysis, nothing but fixed carbon, is can determined indirectly by reducing the total percentage of the 75% from 100%. There is no special test for the fixed carbon. Now we see, since the main component of the coal is carbon, it can be determined by subtracting the sum of the percentage of the moisture, volatile matter and ash content from the 100. That means percentage of the carbon is equal to 100 minus percentage of the moisture and percentage of the volatile matter and percentage of the ash. That means 70% of the analysis is deducted from the cent percent analysis, directly gives the percentage of the fixed carbon. Now we see finally significance of the proximate analysis. So first one, nothing but the moisture content. That means proximate analysis gives the quick and valuable information regarding commercial classification and suitability of the coal for industrial use. That means it consists of a complex mixture of the gaseous and liquid products resulting from the thermal decomposition of a coal. That means the amount of the decomposition and yield of the volatile matter depends on the conditions of the heating, particularly temperature. Now we see first one, moisture content. A high moisture content in the fuel takes some heat liberated in the form of latent heat, reduces the calorific value, increases the cost of the transportation and causes the wastage of the heat. That means hence the lesser the moisture content, the better is the quality of a coal. That means moisture should be inversely proportional to quality of coal. Moisture should be inversely proportional to quality of coal. Okay, so that means but moisture up to 10% produces a uniform fuel bed and less fly ash. Up to 10% it is acceptable level. Above 10% it will be inversely proportional to quality of the coal. Next we see volatile matter. That means it is due to the combustible and non-combustible gases. A coal containing high volatile matter burns with long flame, high smoke and lower calorific value. That means volatile matter is also inversely proportional to calorific value. That means volatile matter also influence the design of the furnace. So since the higher the volatile matter, the larger is the combustion space is required. And the third one, nothing but ash. Ash is a residual incombustible matter produced by the burning of a coal. It creates cleaning and disposable problem. And ash adds impurities in metallurgical operations. It obstructs the flow of the air and heat. That means ash reduces the heating value of coal, and ash content increases the cost of the transportation, handling, storage, and disposal. And finally, it determines the quality of the coal. Hence, the lesser the percentage of the ash, the better the quality of a coal. That means ash is also inversely proportional to quality of coal. And the final one, nothing but fixed carbon. That means higher the fixed carbon in a coal, the greater its calorific value, and better is the quality of a coal. That means the percentage of the FC. FC means fixed carbon will be directly proportional to calorific value. And second one, nothing but quality of coal. So out of the total 4 analysis of the coal, moisture is also inversely proportional, volatile matter is also inversely proportional, and ash percentage is also inversely proportional to quality of the coal. One and only fixed carbon will be directly proportional to quality of the coal and calorific value. That's why we maintain the fixed carbon in high percentage. That means it helps its designing the furnace and shape of the firebox. It increases from low ranking coals such as lignite to high ranking coals such as anthracite. That means in order to improve the ranking of the coal with the improving the percentage of the carbon. That means it helps in the designing furnace and fire box. So this is about the significance of the fixed carbon. And it is about the instrumentation diagram used for proximate analysis. So you see the sample cups are placed in a proximate analyzer. So this is the proximate analyzer, and for automatic measurement of the ash yield, fixed carbon, moisture, and volatile matter. And volatile matter percentage maintained nearby 950 centigrade. We take dried coal sample is very important. Okay, so this is about the proximate analyzer in order to determine the moisture, volatile matter, ash content, and finally fixed carbon proximate analysis. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.